Warm greetings, dear students and learner. I am Dr.J.Porkodi, Assistant Professor of Chemistry, the Standard Farouk's Rajaratnam College for Women, Sivagasi. In this module, we are going to learn about periodic trends and its property. Before entering into the chemistry topic, that is periodic table, we must know some of the basic things about periodic table. Periodic table is first designed by Mendeleev. He saw the solider game, that is nothing but the card, how the cards are arranged. Based on the arrangement of the card, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, Clever. After seeing this card, Mendeleev had a dream to arrange the elements in the periodic table. So, he arranged the elements in the periodic table by using the atomic weight first. Later, Moseley, he refined the periodic table and he arranged the elements in the increasing order of atomic numbers. The elements are arranged based on the physical and chemical behavior, and the periodic trends is as follows: atomic radius, ionic enthalpy, electron affinity, electronegativity are going to be discussed in this module. First one, atomic radii. Atomic radii is nothing but the distance from the center of the nucleus to the outermost shell where the valence electron is present. Covalent radius. What is covalent radius? Two atoms which are linked together by mutual sharing of an electron. They form covalent bond. The molecule that are linked together by means of a covalent bond have covalent radii. Covalent radii is the one half of the internuclear distance between the two identical atoms. And the picture shows that atomic radii and the covalent radius, and it can be measured with the help of X-ray diffraction studies. Next, periodic trends in atomic radii. When we move down the group in the periodic table, the size of the atom get increases. See the picture: lithium, sodium, potassium, rubidium, cesium. The size of the atomic orbital increases because the valence electron is lithium is 2s, sodium is 3s, potassium is 4s, rubidium is 5s, and cesium is 6s. So, as we move down the group in the periodic table, the size of the atom increases, therefore, the atomic radius also increases. And we move across the period, that is when we move from left to right in the periodic table, the atomic radii get decreases. This is because of the effective nuclear charge, and the electrons they are enter into the same shell. Therefore, contraction of the nucleus takes place and the atomic radii get decreases. Next is ionic radii. What is ionic radii? This is nothing but the distance from the nucleus of an ion up to which it has its influence on the valence shell or the electrons cloud. How the ions are formed? The ions are formed when the atom loses electron or it can gain electron. After losing an electron, the atom become cation. After gaining an electron, the atom become anion. The size of the cation is smaller and the size of the anion is larger. In the periodic table, when we move from left to right in the periodic table, the ionic radii is also decreases. This is because of the effective nuclear charge, and we move down the group, the ionic radii get increases. This is because of the larger size of the shell, larger size of the atom. Next one is ionization energy. This is nothing but the energy required to remove the most loosely bound electron, that is the valence electron from the gaseous atom. So, A is an atom. After giving some energy, the A loses an electron and it becomes a cation. When we move down the group, the ionization energy get decreases. This is reverse of atomic radii, because as the size of the atom increases, the nucleus and the valence electron cannot able to see each other and the interaction between them get decreases. So, with the help of small energy, we can able to remove the most loosely valence electron. But when the electron is very near to the nucleus, we have to supply more energy. Then only we can able to remove the electron from the nucleus or from the atom. As we move down the group, the ionization energy decreases. But when we move from left to right in the periodic table, the ionization energy increases because the size of the radius get decreases. So, we have to give more energy, then only we can able to remove the most loosely bound electron. And the next one is the electron affinity. This is the energy that is liberated from the atom when an electron is added to the gaseous atom. So, where in ionization energy the electron is removed, but in electron affinity we are going to add an electron, therefore, the electron is gained by the atom and it become an anion. But in ionization energy the atom removes its electron or the atom loses its electron and it become cation. Electron affinity is also similar to that of the ionization energy. It get decreases when we move down the group and it get increases when we move from left to right in the periodic table because of the effective nuclear charge. And the next one is the electron affinity. Electron affinity is the tendency of an atom to attract its shared pair of electron towards itself. Suppose two atoms, consider hydrogen and chlorine. They are linked together by means of a covalent bond, which is nothing but a mutual sharing of electron. Here chlorine is more electronegative than hydrogen. So, the chlorine has a tendency to attract the shared pair of electron towards itself. This is also the periodic trends is also similar to that of the ionization energy and the electron affinity. Here also as we move down the group, the electronegativity also get decreases, and when we move from left to right in the periodic table, the electronegativity get increases. We are a very familiar example is lithium. This is has very low electronegativity, but fluorine which is have high electronegativity. And in as a conclusion, the atomic radii, when we move from left to right in the periodic table, it get decreases, and it move down the group, it get increases. When the size of the atom increases, the ionization energy get decreases, electron affinity get decreases, and the electronegativity is also decreases. So, ionization energy is inversely proportional to the atomic radii. Atomic radii is inversely proportional to ionic radii, ionization energy, electron affinity and electronegativity. Thank you for visiting this e-content module. We will see in the next module. Hope this will be very useful to study the periodic trends and its property. Thank you.